Okay, this is the session for worksheet 9, which is a little bit complicated, so I'm going to try and do both A and B. Question 1, this is sheet A. Question 1, so worksheet 9. Question was to integrate 0, 1, 0x, 0x minus y, and it's x, dz, dy, dx. This is, kind of straightforward. To integrate this with respect to z, you get constant, so it'd be xz. And you need to plug the two numbers, x minus y and 0, and still integrate from 0x, 0, 1, dy, dx. So, since you're integrating with respect to z, you're going to plug in z. So we first plug x minus y, and then we plug the 0. And that would be dy dx 0x 0, 1. Then take the x inside, x squared x y, this is of course 0, dy dx 0, 1, 0x. So now you need to integrate this with respect to y. X squared is a constant, so it would be x squared y. Integrating this with respect to y, you get 2 over 2. And then you plug x and 0. Those are your limits for the integration. And then you integrate this from 0 to 1. That was integration with respect to y. So we need to plug the two endpoints into y. So it would be x squared, x, x, x squared over 2, and put 0, that gives you 0. So you're integrating, this is x cubed, this is x cubed over 2, 1 x cubed minus half will give you x cubed. X cubed over 2. So 1 minus half is half of x cubed. You integrate this, it would be 4 over 4, and there is a 2, so that's 8. And then you put the 0 and the 1. You put the 1 to the power 4 is 1 over 8, and you put the 0, 0. Answer is 1 over 8. So this is the first question, which is somehow straightforward. Now we'll do question 2A. And you need to be careful here because it's one of those that's not very straightforward. And I'll show you a technique to do it. In fact, I made a mistake in this question when I send you the answer. I'll show you now the correct answer for this question. So you have this, and it's the function in terms of x, y, and z, dz, dy, Okay, now what the question is asking, they want you to change it from this to a different order. They want you to change it to dy, dx, dz. Okay, now what does this mean? Now, listen carefully here. The first integral is in terms of z, and it's limited between the two equations, 1 minus x minus y and 0. The second integral is in terms of y, and it's limited between 1 minus x and 0. And the last integration is x, and it's 0, 1. I'm going to create a table to help you understand this a little bit better. So in this table, we're going to have four by 5, that's good. Create more space, so like this. And you put x, y, z here, put it in terms of x, y, z, and here we say multi, in terms of multivariables. Now, to understand this better, you'll see that with respect to z, you get the two equations. So z, in terms of multiple, you have 1 minus x minus y and 0. This is z in terms of multiple. So z in terms of two variables, so z in terms of multiple between these two. Then the second one would be y in terms of x. Y in terms of x, you have the 1 minus x and the 0. And the dx only numbers, so x in terms of x, so x in terms of x, it's only for the last one because it's numbers and it's 0, 1. Now, what is the question trying to ask? They want you to switch to this. They want y in terms of the two variables. So they want this one here, y in terms of multiple. They also want x in terms of z, x in terms of z. So you want this one here. And they also want z in terms of z, which is the last one, so they want the numbers. So these are the three things we're looking for. Okay, let's try, first of all, what is y? Can we find an equation for y in terms of the two variables? From here, from this one, z equals 1 minus x minus y. If I solve for y, bring the y over, would be 1 minus x minus z. So here, it's 1 minus x minus z. This is the equation for y in terms of both variables, plus I can get y equals 0 also as another option, which is the other limit. So I got this one, good. Now let's see if I can find an equation for x in terms of z. When you get x in terms of z, for this one, set y to 0. If you set y to 0, and remember you want x in terms of z, bring the x over it's 1 minus z. So here, it's 1 minus z, and the other possibility, or the lowest limit, according to this, is 0. So I got the two limits for zz. Now the only thing left is the numbers. If you do z in terms of z, sorry, this is wrong. The last one was z in terms of z as numbers, so we need this one here. So z in terms of z as numbers, well, you can see it here, for example. If you plug the numbers 0 and 0, you get 1 and 0. So obviously, it's between 0 and 1. So once you do this, you can put it in an integral form. So you go 1, 2, 3, the function, and they wanted dy, dx, dz. dy, so y in terms of multiple, so we did it. This is the dy in our case, so we put between 0, 1 minus x minus z. The dx would be x in terms of z. X in terms of z, we put the limits 1 and 1 minus z. And finally, dz, z in terms of z would be 0, 1. So this is the answer for the integral if you switch the order. I'm going to do another example, which was in worksheet B, question 2, worksheet B. So I'll keep the table. I'm going to just make a few adjustments here. And the limits also are different. So question 2b was to integrate 0 to and 0, 1, 0, 1 minus y squared, and it was dz, dy, dx. And they wanted you to switch to the dy dx. Okay, for the first one, means that z is between 1 minus y squared and 0. So z in terms of multiple. Z in terms of multiple would be 1 minus y squared and 0. Then y between 0 and 1. That's y in terms of x. Y, and in terms of x, that would be 0 and 1. So there are no equations, or just basically y equals 1, 1, and y equals 0. Or 0, 1, doesn't matter. And finally, x and numbers would be 0 and 2. The last one would be just x in terms of x. And again, they want this, this, this. First of all, they want to know what this is, which is y in terms of multiple. You'll see that from here, we have the equation. We shall solve for y. You bring the y over, and it's y minus z, then your y would be positive negative root. But since the y is in the positive section, you're not going to see the negative root, so y would be positive root and 0. So in terms of multiple, this would be 1 minus z squared and 0. This is y in terms of multiple. What else? You want x in terms of z. X in terms of z. you'll see there's nothing that relates x to z. So you ask yourself, okay, if I don't have anything that relates x to z, that means that x pretty much constant, so it would be just a 0, 2. Because there is nothing that relates x to z, so it would be just a constant, so you put 0, 2. So we got this one and this one. We only have this one left, z to z. Now z to z, if you notice, the value of z, we can get it from here. If you plug 0, you get z between 0 and 1, and if you plug 1, that would give you 0 again, so it's 0, 1. So this would be 0 and 1. So you go integral, 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 the function, and the order do dy, dx, dz, y in terms of multiple, that would be 0 and the root. I think there was no z here, yeah. And then x in terms of z would be 0, 2. And then finally, z as a number, 0, 1. This would be the answer for question 2b. This is the end for part 1. Part 2 will continue with the questions.